Now, welcome to the second part of this classification matrix tutorial, and now we are in the second half of this class label. And imagine that you have an imbalanced data set. So suppose we have 10k records, and where label A is 9k and label B is 10k. So what I'm trying to say is that, for example, that we have 10k records, right? So in total we have 10k records, and class A is there, a class B is there, and in class there are 9,000 labels, and in class B there are only 1,000 labels, so 9k and 1k, right? Now suppose we are calculating an accuracy, then it is obvious that we'll get 90% accuracy because they are highly imbalanced. So when you train your model, what will happen? The model will focus more on this 9k. So for example, I'm teaching you some content, right? I'm teaching you history and geography, and let's say I have 10 classes to take, and in 9 classes I taught you history, and in 1 class I taught you geography. So you will be more skilled toward history classes because you have been more focused towards your history classes. So same as machine learning model, so you will be biased. And in that cases, it is not a good way of calculating the accuracy, because if we'll calculate the accuracy, the model is biased toward this area and because towards this class, and you will not get the good result. So in such cases, we'll focus upon recall, we'll focus upon calculating the precision, and we'll be calculating F beta score to see that how the performance is given. Now, the first thing is called recall. So, and recall is also known as sensitivity. It is also known as hit rate. It is also known as true positive rate. So recall basically trying to focus on identifying that how many positives we are correctly identified out of the total positive cases. So pretend that there are 1,000 classes, 100 classes, 100 positive cases, and then out of 100 cases, how many successfully we have correctly predicted. So let's say for example, we have 100 COVID cases within the school, and out of that 100 COVID cases, we conducted the test, right? And out of this 100 cases, we said that only 80 are positive and 20 are not positive. So actually they are positive, but we are saying that they are not positive, so that means they are false negative, because these are the positive cases, but we are saying they are not positive, but we are only classifying them as a true positive, that we have identified 80 as a true positive. So to calculate this recall score, we have to say true positive, so that means 80 divided by true positive, again 80 plus 20. So that means our true positive rate is always around 80%, or you can say 0.8, right? So this is how we calculate the our recall rate. So let's say example here, we can calculate the recall score. There can be more than 2 classes also. So what we have decided over here, that we have created more than 2 classes. So 0, 1, 2 there are classes. So why true? In first list there are 3 classes, 0, 1, 2, 0, 1, 2, and their predictions are 0, 2, 1, 0, 0, 1. Right? To calculate the recall score in scikit-learn, there is a function called recall score. So you can easily use this function to calculate. So what you have to do, you have to just use the recall score, and you can calculate it into 3 different methods: macro, micro, and weighted. In macro, what will happen? It calculates the metrics of each level and find their unweighted mean. So that means they will be not given any weightage to that, right? But in case of a micro, what will happen? That it will be counting globally towards the true positive and false negative and false positive, and you will get the score according to that. And when you say weighted, it will weight with the help of the number of samples present over there, and then you will get the score. And you see over here that we have printed recall score, recall score, recall score. In all the 3 cases is 0.3, 0.3, 0.3. Now, if you want to see the classification report, that how well we have classified these two things, so you can use ytrue and yprint and plus the classification report. Target name you have to tell there is a first class 0, 1 and 2, right? Because there are 3 different classes. So it will give you a support which is telling you there are 2 zeros, 2 1 and 2 2. So it will telling you the support. It's showing me the precision is very nice, 0.67, and recall is 1. So that means 0th class is being identified very correctly. So you see over here in the top, 0 is being classified as 0, 0 is being classified as 0. That's why the recall score is 100% for class 0. But for class 1 is predicted 2, for class 1 it's predicted 0. So that means for class 1 it's 0 0. It's showing that very awful performance for class 1. Similarly, class 2 is being predicted as 1 and class 2B is being predicted as 1. So you can still see it's 0. So that means you can get a class wise recall score as well. Now let's see precision, which is called a positive predicted value. So in precision case, say that out of the total predicted positive value, how many results were actually positive. So that means here again we are trying to focus true positive, but we are, instead of finding the false negative, we'll be calculating the false positive rate. So we'll be seeing that how much false positives are there, right? So in case of precision, we deals with false positive. Similarly, we have these two lists in our case. We can use this precision score. From here again we can calculate the value macro, micro and weighted, and you can see we can print the score. Again the same values are coming in case of precision score, so we can easily calculate that. Now the point comes where to use precision and where to use recall. So now let's take an example and clearly try to understand that's what happened. So in our first case is the spam detection. I hope you all know what is a spam detection. Spam detection is a kind of a machine learning model which is inbuilt in our email system, and whenever email comes to us, the machine learning model will try to detect whether it's a spam email or not a spam email. In that case, we have to consider precision. Why precision? So you have seen here in the precision, we mostly focus on false positive, right? So that means we are very much focused in identifying false positive. So what will happening that, for example, you got an email and your model thinks that this is that's a kind of a spam. So for example, you got a job offer and your model is saying that it's a spam, and you didn't get in your inbox, rather than it went to your spam, right? So you have missed a very important appointment just by being an extra cautious, right? So your model is trying to predict this particular email as an spam. So that is a case of a false positive, right? So here in such cases, such type of machine learning problem will try to minimize the precision, right? So we'll try to minimize the precision error, or you can say we'll try to maximize the performance of this, right? So we want as bigger precision as we can, right? Similarly, cancer detection. In cancer detection, what happens that, for example, we'll focus on recall, we'll not focus on a precision, because, for example, a patient went for testing whether that patient is having cancer or not, and for example the test was done, and after the test what we have found that the person is negative, right? But actually the patient was having a cancer, and if somebody is having a cancer and if it is not detected at time, it's going to be a blunder for that particular person, because it can risk the life of that person. And in that case, we'll not focus on precision where false positive are there. In that case, false negative is very important for us. So if any false negative happens, it can cause a big problem to any person, right? And in that case, we'll focus on recall but not precision. So therefore it is important to use recall in such situations. Note, our goal is always to reduce precision and recall, right? So whenever a false positive is very important to us with respect to the problem, then we'll use precision. And if in some cases where false negative has a greater importance, so for example, in case a cancer patient, your false negative should be very less. If you miss any cancer, it can risk a person. And over here, false positive, if your email says that this is a spam, right, you missed an important email, then it's a case of precision, right? So we'll try to reduce these two values as much as we can. So our goal is to get very accurate result, right? Now let's focus on F beta. So sometimes both false negative and false positive and false negative plays an important role in an imbalanced data case. So we have to consider both recall and precision. Both are equally important, and in that case we calculate this F beta score. F beta score is nothing, it's 1 plus beta square precision into recall, beta square precision plus recall. So basically what's happening when value 1 is there, when if beta is equals to 1, this F beta will become an F1 score, what generally we see in our machine learning models. We talk about F1 score, but we don't know what this F1 came from, so where this 1 came from. So the value of beta decide whether it's F1, F2 or F0.5, right? If beta value is 1, F1 will become something like that, because this beta will become 1, right? So 1 plus 1, 2. So that means 2 into precision into recall divided by precision plus recall. So this is how we calculate F1 score. So if both false positive and false negative are equally important in the model, then we have to keep the beta value 1. When we can choose the beta value less than equals to 1 or closer to 0, suppose false positives as having a more impact than a false negative. So in case of a spam detection case, we can choose the value that false importance is very important. I don't want to miss any email. We can choose this beta less, so we can say F0.5 score. So it will more focus on precision rather than recall. And where false negative is very important, we can say we have to increase the value of beta from more than 1 up to 2 or something. And in that case, it will focus more upon the negative thing. It will focus more on false negative. And in that cases, for example, cancer detection, so what will happen, that will more focus upon false negative. Now let's see with the help of Wine dataset. That's an inbuilt dataset in scikit-learn. So we are importing this and we are using a decision tree classifier. So you see I'm loading the data over here. I'm calculating the target names. I'm splitting the data with the train size of 70% and test size of 0.30, right? So there are 3 different classes. So I have to first load the data. I have loaded the data over here. There are 3 different classes, class 0, class 1. I have trained that very simple decision tree model, and after training the model, I'm predicting it on the test set. I'm getting my results in ypredict, and I got it. Now what I'm doing, I'm trying to print 2 different things. First, I'm trying to print my classification report, and second, confusion matrix. So you can see over here that the class is not, the data set is not balanced, it's an imbalance. So first class having 17 representatives, 20 and 17, which is not too much imbalanced, but imbalanced. So these are some results which I'm getting an accuracy of around 85%. And if I want to see that how well I did class wise, so 14, 15 and 17, these are the true positive values which we are getting. And this is all the summary. So I hope you like this, and it will help you in your data science career. If you have any query or doubt, please leave your comments. Thank you for watching Class of AI. I'll see you in the next video.